Is this working? Yeah, great. Okay. I have to switch up. I think this needs to be my mic hand. Let's do it. Yeah, well, good morning, everybody. How was Sublime? Was it good? Was it Sublime? That's bad. My name is Aaron Rosenmund. I did not go to Sublime. Someone told me they're coming on at 11. I was like, I'll totally show up at 9 and then like peace out after the first set. And they're like, nope, that Sublime's not coming on at 9. So that didn't happen. Thanks for coming to my talk. Let's collect all the data, protect all the things. Definitely stolen from dual cores, drink all the booze and hack all the things, right? Except from the blue team side where we have to be responsible, right? Oh no. Oh, did it work? Did it not work? You have to turn these on. Hold on. All right, so I work for Pluralsight as a staff author full-time. They make a bunch of e-learning content. I make security content, even though they didn't give me the benefit of having an icon. But I do work specifically on security event triage. Right now, I'm working on path on that, and there's a bunch of courses in that area that I've created and worked with others to create that talk about a lot of the same concepts that are in this presentation. Part-time, I work for the Florida Air National Guard in Defensive Cyber Operations. And because of that, last week I was on 12-hour standby orders waiting to go support the hurricane. I'm not really sure what I would do as a defensive cyber operator to support hurricane defensives because they're actually going to send me to Camp Blanding. So I wasn't going to have to do anything with computers. I was just going to sit on cot for 3 days. But while I was looking for how to fight a hurricane, I did find this little picture of Daniel fighting the hurricane. And I decided that if I did go fight a hurricane, I would want to do it with a tiger just like him. So coming up, we're going to go over all kinds of stuff. And the point I asked about making sure the slides are available because there's a ton of information. There's like 90 slides, there's 45 minutes. I thought I was going to do it in like 30-ish minutes, so I'd leave time for questions. So I'm going to try not to go too quickly. However, don't worry about writing everything down, right? The point is I'm exposing you guys to a bunch of different things. It's all going to be open source stuff. The idea is that if you have commercial solutions in your environment, but you aren't filling some data gap or some analysis hole with something, then you can use one of these tools to fill that gap and then integrate it into your security operations. So we're going to talk about collecting security data, different types of data, different types of tools to do analysis with that. And then at the end, we're going to kind of wrap that all up and talk about pulling all that data into a SIEM. And I'm not going to talk about security orchestration automation because there's plenty of vendors talking about that right now. But the idea is that we'll go through the data flow of how you would use this information to do two things. One, we're going to take all these alerts that we get, and we're going to single those alerts out into really important alerts. And those are the new important alerts, and then we're going to correlate those alerts and make it where, at the end of the day, we're kind of looking at only things that are true positives, right? So the hurricane thing, we're going to bring that back up because it just happened to me. It's important to my life, so now you guys have to listen to me talk about it. I was on 12-hour standby orders. Last year, I actually lived in Panama City Beach. It got hit by a Cat 5 hurricane, Hurricane Michael. And then I moved to Jacksonville, Florida, and it almost got hit by a hurricane. That was a Cat 5. So then I'm like, well, I do a lot of pattern analysis for my work. Maybe I need to figure out if I'm exposing myself to too much risk by living in Florida. I look up NOAA's data. They have 150 years of hurricane data. And this is what that looks like on tracks threatening North America. And it basically like blanks out Florida. And I was like, well, that's probably not a great idea. But based on that, I was like, well, I know that I need to like normalize data and kind of get a better picture of what's actually going on. So I just made it like, what's my specific threat, which is kind of what we do, right? So my specific threat is 200 miles around Jacksonville, Florida, because I figure, with the cone of probability, it could really go anywhere. But that still looks pretty scary. I still can't see Florida, right? And then I reduced that down. We're looking like, let's only talk about Cat 4 and 5 hurricanes. I don't know who lives in Florida, who's threatened by hurricanes very often. But the Cat 4 and 5s are the really scary ones. The Cat 3, I'm still going to hang out and just drink all day. So then you sanitize that data because some of the stuff was old, and you only get about like 6 hurricanes. That's not too bad, right? So it looked like really scary, and I was not super scary, but I did reduce things to threats that I'm actually concerned about. And then I graphed that because that's what we do. We graph things. And it looks like there is potentially some sort of trend. And I just use my eyes. I'm not using machine learning. I'm just using my eyes to identify there's some sort of clustering on the right side there. And then just because it's like, important right now in the environment, let's talk about temperatures and how they change. So this is the anomalous temperatures over time. Is there some sort of trend there? Maybe, I don't know, I'm not a scientist, right? But the idea is that there's patterns everywhere. And there's gonna be a lot of patterns in this talk. So some of the patterns we're gonna talk about is how we do security analysis. And I don't care what vendor you talk to or what product you use. But basically, all we ever do is collect things, aggregate them, and search through them, right? And we do it over and over and over and over. And so it's going to kind of be a pattern in this talk when we look at different data that we're going to collect the data, we're going to aggregate it and normalize it, and we're going to like search through it for stuff we care about. We do something called baselining, which is really important. A lot of people talk about doing baselining with humans. We shouldn't do baselining with humans because there's too much data. We do it with computers. We identify those deviations from the baseline, and then we leverage what we call machine learning, which is really just like fancy statistics over time, right? You do outliers, you make that over a time period, and now everybody calls it machine learning. So that's cool. Security operations. So this is, 861R2 is the NIST document that talks about incident response. I'm not basing it on this. This is more talking about how your teams work together in Security Operations Center, right? You identify stuff, you respond to the stuff, you look at what the root cause was, and then you use that root cause to fortify your stuff. You're either making better detections or you're securing your network. And then the really important part, and probably the only time I get to talk about this in this talk, because we have a bunch of stuff to cover, is that you got to emulate that threat to make sure that with the fortifications that you did actually worked, right? So just remember that for your security operations teams. That's why we have so many teams in security. So MITRE, I like to use them because they support things that I think a lot, not on purpose. It's just we happen to think a lot of the same things, so it's great. I get to leverage their name. But MITRE ATT&CK, everybody likes that. They're saying that we have to collect all the data too. And they have this really cool graph. If you haven't found it, it's on their blog. And you can look at this graphic and identify every single tactic, technique, or procedure and how it ties to a data source that you need to detect it. Right, so it's pretty neat. And then I have to talk about Stuxnet because it's a security talk and everybody has to talk about Stuxnet at least once, right? This is the only Stuxnet slide, so don't get too concerned, but I really do enjoy this piece because of the AC/DC thing. If anyone knows the reference, notionally around the third time whoever it was that attacked the Iranian centrifuge center did that, they actually played Thunderstruck over the speakers first, which is just kind of awesome. If you're that security operations guy in charge of that facility and you come into work and then you start hearing American rock music over the speakers, you're like, oh no. And then second, you're like, okay, that was pretty cool. And then third, you're prepping your resume, right? And the only other reason I bring this up is because Stuxnet, as we know, didn't come over the network. It didn't matter how many security provisions you had at the edge of your boundary looking at the network and inspecting the network, because a lot of times where we start, it didn't come that way. It came through a USB that someone downloaded something on and then plugged it into the wrong thing, right? So that's important. Let's keep that in mind. Because a lot of companies start with security and start with security monitoring on the network. And we're going to start with that too. But the idea is like first you get a firewall and then you get network monitoring. A lot of times you just keep focusing on your ingress egress, right? And when you do that, you're kind of like a chicken nugget. You're really crunchy on the outside. And then you have this soft, like unknown quantum realm on the inside where you don't really know what's happening. But likely the cat's dead. So if you didn't get that joke, that's fine. I just assumed we had the same crowd here that like quantum physics and like cybersecurity. It's fine. So let's start with network. What do we do? This is beyond the firewall. So we're really talking about security analysis and monitoring. So we're going to start talking about signatures. And they're not my favorite, but we got to talk about them because you got to do this first. You have a big signature list. This is all the stuff that's known. You can use Snort, you can use Suricata. No one brings up Snort anymore after Cisco bought them. I don't know what the deal is. I get that Suricata is multi-threaded, but whatever. So when we look at Snort rules, something interesting happened. So this is a scan that was sequential. It's an nmap scan. Just started at 0, went to 65,535. But what is peculiar is that the only thing that alerted is very specific things, and that's how security signatures work, right? And we look at that signature saying, okay, we only cared about this port and TCP connections with a SYN packet that happened 5 times in 60 seconds. So it's like a super specific use case that someone else thought of as a scan. So if you do anything other than that, if you did it like 4 times, it's not getting caught, right? Same thing for this nmap OS detection. So it's really cool that this description says nmap OS detection. You're like, man, Snort's like really good. And this is like some guy just wrote this, right? Like that's all it is. It's just a description that some guy wrote. And he said, hey, I noticed that when nmap does OS probes, it's full of the letter C, like a lot of C's. And so if you see like a lot of C's, that's nmap, right? It's like, oh, that's good. I wonder if AMAP uses A's. I don't know. But there's a reason that's not good enough, right? If we change that, if we do anything else, it doesn't get detected. So around that same time, for that data set, there was a PowerShell scan done. So I use PowerShell for everything because it's awesome. I do PowerShell scanning. It does like some unique scanning behavior, so it's kind of hard to detect, but especially internally, it's already on your box, right? So if you're already compromised and you're inside in this squishy quantum realm, you can laterally move and do lateral enumeration using PowerShell. No one will ever find you. It's a tool that's already there. It's like a law bin, right? But what you can do is use bro. I love bro. I'm going to bring it up a bunch. You can use bro. It's Zeke now. I got it. I'm going to call it bro. When you type it in and you press enter, you have to type bro. Otherwise, it doesn't work. So it's still bro. So you can look at connections that were attempted, and you can look at that internally, and you can do kind of the same idea. So it doesn't matter if it's a SYN packet or UDP or what it is. It's just more of a behavioral analysis of that session, right? So this is a bro script that was written custom for this. And it detects that internal scanning, even from PowerShell. It doesn't care what your scanner is, doesn't care what is inside that packet, it'll detect that. So that's something that's important. And it also, did that change? No, it's the next slide, cool. So the other thing I want to talk about is intervening. So we're internal. Endpoints don't need to talk to endpoints, right? Or unless they do, if you have some specific use case, then great, but make that a whitelist thing, right? So you have to segment your network and you look across those segments internally, and there's only specific reasons that endpoints need to be talking to other endpoints. Great. So then we move to Malloc. It's made by AOL, like the AOL that we use for messaging and dial-up. They like do cybersecurity now. I don't know. But Malloc is amazing. It visualizes all that session data that we're talking about. And this is the really cool part, because if you're not a security analyst, you're about to become one, I hope. We'll see. So we're looking at sessions here. That graph up there is just the count of the sessions, right? Not very interesting. But then we can kind of change the view, and now we're changing this graphical view to show us something else that we can kind of baseline with our eyes. So everybody do some mental baselining now, and we can see that, yeah, it's about 50-50 to output and input of packets in the network, right? But if we change that, and instead we look at data bytes, right? We just changed these view a few times. We've now identified an oil rig actor. This is actually actual incident response. We're pulling stuff down. Oil rig does uploads over SSL to Google Drive, right? So Google Drive looks totally legit. It's hard to find. Companies use Google Drive all the time, but they don't use it this much, right? Especially in a short period of time. So if you can see that, if you can see that bump in red, you just detected oil rig actor. Good job, everybody. Well done. So that's kind of network stuff. And there's tons of ways we can expand upon that, a bunch of different use cases, but there's just some tools and ways to use that, right? Machine data. So I'm kind of definitely arbitrarily separating the different types of data types that we use, but this is the best way I could figure out how to do it. So we're talking about network stuff first, and that's own packets flying around on your network, whether it's internal to external or inside your network. And now we're going to talk about machine data. Machine data is any of the devices, but localized to that device. So this is where I'm kind of drawing the line for machine data. So we're talking about stuff on that box. So if it's a Windows box, it's the logs for the local device. If we're talking about a Linux box, it's the logs for the local Linux box. If it's a Cisco device or an ESXi, or whether you're using Juniper or whatever it is, it's the logs that are local to that device that are unique to it. So you can log into it as opposed to logging into a service. And that's where we're looking at different things here, right? And so here's a great use case. I use Elastic for everything because everybody else does too, and it's free, and it's part of the open source stack that is starting to be really common in the community. And if we're looking at a web server, whether you host that in the cloud or you host it somewhere else, and you see different logins locally. So first of all, you should be using RSA keys. So if you're not, do that. But also, root shouldn't be allowed to log in over SSH. So if it is, and that's a policy that you have, a good reason to know your policies, then that's a weird anomaly. As well as if you have one account that's supposed to be gAdmin, but you see a bunch of other accounts logging in, that's also a weird anomaly, right? And then if all of a sudden this activity stops, they probably succeeded. And then what they'll do after succeeding, and this is some data you can pull out of those logs, is you can identify that they created a new user, and then they elevated that user to sudo privileges, right? So that's another little data point we can use. You can do the same thing with Windows logs. And here's SMB logins. That's not always like really well tracked and understood, especially the failures. In the top left, if you look at that spike, we can tell that that's like kind of weird, right? So these are just general SMB logins. And so whether it's to a shared drive or whatever it is, we're looking at that, that file share. That's where we're looking at those local logs, right? And so that SMB login is kind of normal. People maybe come to work and then it bumps in, but that spike is kind of strange. So now we're going to look deeper. And if we look in baseline again with our eyes, looking across, saying, hey, the pattern here is that there's a really small percentage of failures, that's the blue, and successes are the green, right? And I type my password in wrong all the time. And even with, if you're using like two-factor authentication, you use your PIN, that happens wrong a lot too, right? So it's okay to have failures. You have to understand that the failure is not the anomaly. The change in the ratio of failures to successes is an anomaly, especially this large of a change. Now, this is really easy for us to detect. This was on purpose. We simulated this with THC Hydra. And then like the last time we were looking at malloc and we see that data exfiltration, that's cool, but I'm not always just staring at the screen. So I need something to do it for me. I call it AI. That's definitely a joke. Totally not AI. That's statistical regression analysis is what that's called. Again, it's outliers over time, right? So we're getting a baseline average over time. They're saying, oh, this is like really high outside that average. That's all it is. It's like X mean. So, but what this will do for us automatically is identify this as an anomaly. Like how much of an outlier is it? And then we can use this as an alert. This is our new alert that we leverage, right? So instead of snort alerts or Suricata signatures, this is now an alert that we can use as an anomaly. And the other thing is I really, really like this type of analysis for the data. It's called, man, this is really squeaky. Sorry if this is too squeaky, guys. But anyway, I really like this type of data analysis. It's called population analysis. And so what we're doing is using that same data. We're still looking at just local log data, right? And we're saying, hey, well, these columns in here, we have like usernames and we have like audit success or failure. And then we have IPs and all that. And so it's nice that we understood that there's something weird going on. But what we really need to do is understand who's doing it. And so if we look at a population, we say who's being weird in reference to their neighbor is essentially what we're saying. When you select a key value, and that key value is going to be audit failures. So like who logs in like incorrectly the most in reference to their neighbor, right? And this is what it does. It caught Steve Rogers doing it, which is weird for a few reasons. Like the first reason is because it's bad that he's running THC Hydra. It's also strange because I think based on Endgame, he's like 200 years old now and he knows how to use THC Hydra. It's very odd. Thank you. So the other cool thing I want to talk about is graph theory. This is also available. We talk about network connections, and it's really easy to imagine in your mind how those nodes connect, and we can draw lines between them and talk about amount of traffic between them, that kind of stuff. You can also do that with logins in like syslog or security data on a local device. So we're now taking these columns, and what graph theory essentially says is that records that are similar will show up as linked based on their algorithm. That's as much as I know about it, right? But what ends up happening is if we say we want users and IPs and usernames and device names. That's what it is. So if we want all those things, we can get this awesome connection of users logging into boxes, logging into device names that can start to give us some more information about what's happening in our network, who's logging in where. If one person's logging into a bunch of places, but they're not an admin, it's kind of strange, right? So it's kind of a cool tool to use. All right, the next part, this is my favorite part. There's a bunch of like proof of concept here, right? And this is not something we get to do a lot as blue team. We don't get a lot of POCs as blue team. There's also side channel stuff here. So all of this stuff is resource usage. It's basically anything you can get from Procmon on any device, as well as network devices have this available as well, right? So we're going to look through all these things. And then here's one. So we're looking at RAM, and you can see that little red spike. But we can also see that at the same time that that red spike happened, that RAM was used up in full, but there's a PowerShell process that's using quite a bit of the CPU. So when we cross-reference that information, maybe that's something interesting. Maybe it's not, but it's still something we can use as an anomaly. Now, here's NIC packets out. I'm not monitoring the network. I'm just looking at the device and the resource usage of that NIC, of that hardware piece, and it's going to tell me how many packets are going out. And when I pull that from multiple devices across the network, I can see if there's a spike here, right? And this is another simulation, right? Proof of concept stuff. But when at the same time that spike happened, we can again use our friendly AI to detect it for us and turn that into an anomaly, right? And we can at the same time see that this GoCannon executable is run. This is a Golang DOS simulation tool, right? And what this is doing is spiking CPU and RAM at the same time that that network spike's happening. So that is most certainly an anomaly and something that you can detect in your network, and all we're using is resource usage data. Now, this gets a little cooler. If you're on a Linux device, there's a user space and program called NICE, and feel free to correct me on the exact terminology for this, but it makes CPU syscalls, right, to prioritize where the queuing of a process in the CPU. And it's generally, if you baseline this across a network, it's generally a very small percentage, right? It's not supposed to be that giant blue thing that you see there. I get that the zeros are up, but the blue is showing nice, right? And that's weird to have happen in the first place, but that's exactly what happens anytime you use a CPU crypto miner, right? It's going to prioritize the CPU calls to use for mining. So that's cryptojacking is when you visit like a web page and someone's got some malicious code in there, and the malicious code is going to leverage through your browser the CPU to do mining, right? What's interesting about it is that it runs under the browser process. So it's kind of hard to detect, but this is a 100% positive signature for that activity, right? Now, air gap hopping. This is kind of cool. Wrote a Python program that takes data. So if you imagine If you don't know what air gap hopping is, well, it's DerbyCon. You should know what air gap hopping is. But if you don't, what happens is you have isolated networks that you feel are secure because they're not connected to the dirty internet, right? But generally, anytime you're in a room with that, you also need to watch your cat videos. So you have another device in the same room attached to the internet, right? And this happens in any like secure space or any place there's like sensitive information. And that network that's not attached to the internet gets updated over like little CDs, or not USBs, but mostly CDs really, and on a really slow schedule. But just like we know with like CC Cleaner, you can do software supply chain interdiction and still infect that system. So you're not actually safe, but how do you get the data out? Well, now we have to hop this air gap back out. A lot of things don't allow things to be put on USB drives and that kind of stuff, so we're kind of limited in that way. But here is a set of like side channel attacks, and one of them is audio. So you can actually manipulate fan speed to transmit binary data, and then have the one that you're watching cat videos on be compromised through normal means like phishing, and be listening for that data, and it'll transmit. This is very slow. This is an advanced threat that's going to take time to transmit this data out. But if this is in a data center, it's where someone isn't, then it's not going to be noticed at all. But you can monitor this resource data usage and understand that this fan speed shouldn't be acting in a binary manner. So that's one way to detect that. Cool. And here's kind of POC for supply chain interdiction. This was actually done in environments like 10 years ago. Huawei put Cisco stickers on some stuff and then distributed it through a Canadian distributor to the DoD, and the DoD put it in all their data networks, right? So this is released. It's not like secret stuff. And what those were, they had extra chips on them that were sending stuff back to OCSP responder and exfiltrating data. So it's bad. But how do you figure that out? If it looks like Cisco and acts like Cisco, like how do you really know? Well, if the motherboard is different, it's going to use voltage differently, right? And especially in reference to how a load is applied. So if you get enough devices, and this is where data is important, we can identify these patterns. If you get enough devices and you track what distributors gave you which devices, you can look at like devices and their power usage, and then map that to the associated network load. And if they're not moving in kind, we can use that population analysis to identify that they're different, then that's something that potentially is hardware supply chain interdiction, right? I say potentially because you have to then go like really inspect that and figure it out. But otherwise, it's really difficult to identify. Cool. So let's move on to endpoint analysis. Endpoint analysis, I'm classifying as anything that's associated with like the OS, essentially, is where we're looking at, right? So we talked about sysmon, sysinternals. Sysmon essentially makes another log, and then logs a whole bunch of OS activity on Windows devices, and is a really good security tool and data resource for that. PowerShell is awesome. Told you we talked about it a lot. You can do anything with it. It's also on Linux. It's also on every device. So this is a part where I talk about just because you don't have software doesn't mean you can't do security, right? So there's a lot of environments where you can't necessarily just load stuff. You have to get approval to load things. But PowerShell is already there. Users can use PowerShell. You don't even have to be an admin, right? And you can do stuff like this. We'll talk about OS query later. But you can do asset detection passively, because the first thing you need to be concerned about is what stuff do you have versus what stuff's new, right? So if you're doing like super advanced security practices, but you don't know what devices are supposed to be on what subnet, or like what one device does versus another, then you're like messing up. You need to go back and you have to do asset detection, understand what is actually in your environment, and understand how that changes. Grass Marlin's a tool. It's free. It is from the NSA. Yes, that NSA. But they have a whole bunch of other tools, right? Like Ghidra. Who likes Ghidra? I love Ghidra. But what this does is it'll passively listen to your network, and it'll build an asset list of stuff that's on each subnet, right? And you can export that as a CSV and use that as intelligence and add that into the rest of your security workflow. So with PowerShell, you can do all kinds of stuff. You can query a bunch of things. We talked about how we can do scans. And that same scan that was used maliciously to scan stuff internally, you can use to scan your own network to do asset detection, right? And so what this is just a simple script that's scanning for some really common ports on a specific subnet. And it's also pulling back TTL. So time to live will indicate, especially 128 within the same subnet, we're talking about Windows boxes. 64 indicates something that's probably a Unix device, right? Which is interesting because if your entire subnet's supposed to be Windows and then you identify a 64 TTL, either somebody's live booting to like Kali Linux, or you have a device like a Raspberry Pi that shouldn't be there. Like there's something interesting going on, and that's something that you can inspect, right? Another thing is like your Windows box probably shouldn't be running as an endpoint HTTP server. So if that's responding true, that's also weird. So you can identify stuff. This was ran as a user, right? So I didn't need any special privileges to be able to do this. You can do this on any subnet that you're on. You can even map out your entire network using TTL. And you can do this activity without having any permission. So I want to bring up Sigma. Sigma is a tool that's using stuff like Sysmon, like we talked about earlier, to give you essentially XML signatures. So we have like snort and start Kah signatures for network. Sigma is your signature for your OS logs, right? So it's going to identify, and they're totally mapped to like MITRE attack techniques and procedures. So each one has like, hey, this is this MITRE attack technique, or this is this potential actor. And then here's how we catch it. And it's generally multiple different anomalies within logs lined up together, right? So it's a really good like behavioral analysis tool to identify these different activities like UAC bypass or Mimikatz running. And what it does is it generalizes that XML format into a signature, then allows you to convert that into Splunk or into Elastic or whatever query for what you're using. I think they're expanding into IBM Q Radar or different things, but as you develop signatures, definitely upload it. It's the whole point of having open source stuff, right? And then if you have a scene that you want to use, then you can help this guy out too. OS Query is awesome. There's a bunch of commercial companies that use it. Capital One, Adobe, lots of people are using this commercially. It's an open source tool. You deploy this as an agent. What's really neat about it is it can run on Mac OS, it can run on Unix, it can run on Windows. It doesn't really matter. And you can turn that OS into a relational database. Facebook made it, so thanks to them. And then you can query those devices. And if you add that with something called Collide Fleet, and then you add that to the Elastic Stack, so again, we like have the agent to collect the data. We're going to aggregate that data, and then we're going to search through that data, right? And so when we search through that data, we can identify nifty stuff that you wouldn't otherwise be able to identify, like Mac OS. You don't really think about searching for malware on it, but you can with OS Query. And so that GitHub there actually has a ton of different queries. I think there's like 100 different ones that are looking for different types of things like rootkits. And while we're talking about rootkits, and we're talking about multiple types of data, if you have OS Query on a box, you can do something like a netstat and get back those network connections, right? But if you're also listening to the network traffic that's happening on that subnet, you can say, hey, there's traffic coming from this box that isn't on my netstat connection. So what does that mean? You take those things together, it means you got a rootkit, right? There's something lying to you. So that's a pretty important anomaly. So next we're going to talk about application data, and we are almost done. I don't know, what's the time look like? Oh, see, it is early. It's fine. All right, so application data. Now, drawn another arbitrary line, this is like everything else. So it's applications that you make that hopefully have logs. That's important. I just talked to another organization. They're like, yeah, logs are important, right? I'm like, yeah, totally. And if you make, I noticed that your application doesn't generate any. And so you have no idea if anyone's abusing it. So you need to make sure that you're generating logs if you are an application developer. And then all these services like DNS, DHCP, LDAP, all of those have logs. And those are services running over the network. They're abused all the time. Apache, SharePoint, Django, Flask, everything has logs that are going to be generated that you can use and you can baseline, right? So we're going to collect it. You can normalize that with Logstash. Logstash is an awesome tool. If you don't have like some sort of specific parser for your logs, you can use Logstash to parse it into a type of data that's going to work where you can use that in your SIEM and you can correlate with other data as well. And I want to bring up Azure Sentinel. It's in beta right now. If you're using Azure, you can add this to your stack for free. And I say for free because it's not quite for free because everything that requires data costs money in the cloud, right? But it is very cool. It's kind of a SIEM that can pull in all types of data like Active Directory AD monitoring. And you can also use it for Office 365. And you can link it in with a whole bunch of other stuff. There's a ton of connectors for this that they're allowing you to pull in. And you can do the same thing that we always do. We can collect all the data. We can baseline that data. It'll identify anomalies for you. So when we're talking about login anomalies, it'll do that too. And here it's using GUIP data and frequency of login to identify anomalies using some additional statistical regression analysis as well here. But it's doing the same thing in that cloud environment. So it's a really good way to be able to monitor that stuff and monitor it in the cloud. And the really neat idea about Azure Sentinel is that it'll scale. You don't have to worry about building this stuff on the back end. So everything else you have to build on the back end. This will scale as you add in sources automatically. And GUIP data and the TTL that we talked about before, that's all protocol metadata. So it's like a story that the data tells, which is how I like to envision it. And you can make any story about the data that you want. And this is where we derive the behavior that the data is telling us it's doing. And then we identify how that behavior is different, right? So one of my favorite ones is DNS entropy. It uses Shannon entropy. It's actually called string entropy. So it's the randomness of a string is assigned a number, right? And you can use, guess what? We're going to use bro because bro's awesome. So we're going to use bro and we're going to identify in DNS logs places where those strings are random. When we see those random strings like that in a subdomain, that means it's encrypted. And same thing when you're looking through like an executable, you look at the entropy of the data in that executable. You can identify places that are encrypted based on high entropy. Same thing with any string, right? So we're looking at DNS queries, whether it's with Bro or if you're just pulling those directly from your DNS server, that's fine too. You can use passive DNS, you can use whatever you want, but you can do this DNS entropy calculation to kind of baseline what the average entropy in your environment is. And so here's a sign that is like 4.6. So anything over 4.6 ends up being an alert. This is too random of a string, and it was 100% positive for encrypted subdomain information. So this is DNS command and control going in and out, and or exfiltration or whatever it may be. The next thing I like to talk about is JA3. And Salesforce made this. What it does is it takes cipher suites and TLS. So just kind of baseline everybody on TLS. Essentially, if I want to talk to you, you have a certificate, we verify certificates are good, but then we also need to verify that we're going to use the same encryption, right? So TLS goes encrypted over the internet. So I'm going to say, I have these cipher suites available because my programming says I have these libraries available, right? And these libraries will say, I have ESCDA or whatever that I can talk to you in. You're going to choose the highest encryption method that you have as well, and then we're going to decide to exchange keys over that method and communicate, right? So what this does is take all those available cipher suites from either end of the communication and creates a MD5 hash out of those strings that are kind of put together, right? And when you do that, you get application signatures based on network traffic, which is really cool. So you can't look inside that encrypted traffic, but what you can do is understand what application is making that encrypted traffic. So you don't always need to do like SSL offloading because it's expensive and hard and you have to put it in the right place. But what you can do is identify what should be on your network and whitelist that. So we look at 3 hours and kind of like a simulated smaller network of office activity. There's only like 18 different hashes. And so you can whitelist that stuff. And then also it's really important you look at the least frequent case. So just because it happened 1 time or 4 times doesn't mean it's bad, but it may be. And so you need to go understand that maybe that's a specific application for that user, whitelist it, and then now all you have to do is like look for the next JA3 hash that pops up, right? And malware, if you think about malware authors, they're not updating all their cipher suites and their libraries very often, right? It takes work, it's hard, they're not Microsoft, they don't have a huge development team. And so they're going to have unique signatures for this as well. So when you put it all together, guess who's at the center of it? Guess whose heart? It's you. And the point is that the analyst, you need all this stuff in one place, right? If we look at Kibana, Elastic 7.0 came out with security seam, which is really great because it's going in the perfect, correct direction. And when we look at what sources that seam can take, it's all the sources we talked about. It's endpoint data, it's NetFlow, it's Windows event logs, it's Zeek logs. They should have called it Bro because it's still Bro. It's fine. But it's everything that we need all in one place. But that's still like a lot of data. So we have to filter that data, and then we need to create out of that data. Just because it's alert doesn't mean it's an important alert. We take the important alerts and we shove that into something I categorize as workflow management system, right? It's your workflow management for security operations. The Hive project is an open source version of that. So the Hive project will take all of those alerts that we talked about, and you can dump them into yet another bucket, right? So we're collecting data, but the data now is just alert data, and we're going to analyze that data and correlate it with atomic indicators that are similar. Then you can create tasks that go investigate that stuff. And then you can look at trends that occur in that atomic data as well as your case data. And you can manage your analyst. Everybody can have a login and work through this. And you can manage how you approach different events that you're working on that are a higher likelihood of true positive, right? And then you're generating intelligence. So the Hive project, the Cortex piece of that Hive project, can take in like 30 different types of intelligence. One of them is MISP, so it's the malware information sharing platform. And what that does is it takes intelligence and applies it to those atomic indicators that you have. And so intelligence is generated by anybody else, but it's also generated by you, right? So when you're participating with MISP, you're sharing out your intelligence and indicators that you're getting, and so is everybody else, right? And so that kind of crowdsourcing of information allows you to enrich that data. And then the really cool part about threat intelligence data is that if you have one atomic indicator, maybe you're not alerting on the rest of what's happening, but someone else might have seen that. So what you can get is other indicators that may be connected that you can now go look for. So that enriched data helps you like vector your search as you triage these events. And that kind of leads into our operations workflow, and which is going to be a high level of everything that we just talked about, right? So we kind of went really deep. I talked about a whole bunch of different projects. But really, here's what we're doing. We're taking all these different like stovepipes of data, and we have kind of signature analysis, we have behavioral analysis techniques, we have machine learning alerts, all that different stuff. And we're throwing all of those alerts into a seam. So this is a really, really big bucket. And then with all those alerts in that location, we're going to filter those. We're going to filter those on things that are important to us, whether high priority or the unique use cases or something that's important to our environment or whatever it is. We're going to tailor those alerts down because we're not inspecting all of them. And this is all going to be done, automatically with queries that you develop over time. That's your hunt team. And then we're going to take all of those and then we're going to shove them into that workflow management system. That workflow management system is going to take all those alerts, and as they pop in there slowly, I don't really have anything to say why this happens. I should have made that faster. As they pop in there, it's going to aggregate those, right? It's going to find things that correlate. So we just took all of the logs in the world, looked at only the ones we cared about, and then now we're looking at only events that correlate. So we have a really high probability that something's happening here. So we're not interrogating everything. We're only using our limited workforce to look at the things that matter. So there's a high likelihood that these related things are going to be something malicious. So this workflow management system is going to combine those indicators for us. It's going to run a task that leverages all that threat intelligence to enrich that data, right? So we have more information for when we go to do that triage. And you can create cases. And then you're going to assign tasks to those cases. And that can be according to a template. That can be based on the type of alerts that you get. You can assign different types of tasks, right? So this can also happen automatically as like management for your team. And then you're going to analyze those trends over time and then donate back to the community with your threat intelligence. And that's the workflow that we work through. And that's a lot. And if you have some pieces that you want to fit in to your commercial applications already, or if you have nothing and you're curious about how to build this yourself with all these open source tools, there is a GitHub with a team that I work on called Identified. We call it Protoss because then we get to use the cool unit names for different things, right? Yeah, thanks. And the Zlot build is definitely going to be a laptop. That one is 100% complete with step-by-step commands to run for a CentOS device that leverages all of these data sources and then combines them all into one place and then runs that entire workflow management for you, right? So that's all done. The mothership build has the concepts there. Some of it's done. It's a lot more difficult when you scale this out to a data center to like tell you how to run different commands on your Cisco devices, right? So that's where we're kind of working through some of that, but there's a lot done there as well as the way that you can scale this stuff across your data center. And here's a list of super cool projects. There's some stuff I talked about, some stuff I didn't. I do want to point out EE Outliers at the bottom left. Yeah, at the bottom left. Donovan, I met him at first.org this year, and this guy gets it, right? If you go to that project, he's looking at outliers and he doesn't say machine learning once, right? So I really like that because it's not. He's just looking at outliers in any type of data set. And it's really, really effective. This sits over the top of Elastic. So again, we can pull any type of data, shove that into Elastic backend, run EE outliers at the top of it, and it'll identify the statistical outliers, those least frequent cases, which is if you've used like Elastic's query language, it's kind of difficult to get to the least frequent. It's not like an easy query to do all the time, but this will help you do that as well. Cool. And that's it. Thank you. Questions? Someone ask at least one question, I'm going to be personally offended. Thank you. Yeah, there's a project called J3er, like ja3er.com. It's got 1,600 different hashes in it. Actually, just updated yesterday. We did a course with Pluralsight with Tyler Hudak. Say hi, Tyler. There he is. We did a course with him yesterday, and we identified a new J3 hash for a TrickBot client that was updated 2 weeks ago. And donated it to that. So that's a really good way of doing that. But also just monitor your network. Look for client side because your server side stuff's going to be really random, right? It's just, all the servers are going to be different. But if you just look client side at your J3 hashes, monitor it, and then just sort by unique, you're going to get a pretty good baseline of what should be there. But then you need to go inspect. So anything like when you looked at the data that we had, it's going to look way different for you. You're going to have like 10,000 this, 10,000 that. But if you have something that's like statistically significant in a small manner, you go find out what that is, and you just add that to your baseline. So there's a little bit of work to do there, right? But as you do that, mainly looking at the smaller cases, you can develop that whitelist. Yeah, cool. Anybody else? Yep. Unique case. All right, sweet. I was like, I'm not sure I'm gonna remember. Yeah. What you got? Thank you. Yeah, I'm not really sure. I'm not like a developer.